I have some slides I'm going to go through here, and then, but feel free to ask questions in the chat here. I have this up the whole time, and I can answer questions while I'm going or at the end. So let's get started. So my presentation is extending DNS with ENS. So ENS, of course, is the Ethereum name service. My name is Brantly Millegan. I work for an organization called True Names Limited, which is a Singaporean nonprofit, although I live in Oregon. And we are the de facto managers of the open source project, the Ethereum name service. So like nobody works for ENS. It's kind of like nobody works for Ethereum, but maybe there's people who work for the Ethereum Foundation. We have sort of a similar thing. So I work for True Names Limited, although we're sort of like the de facto managers of the Ethereum name service open source project. That's our GitHub, our website, and our lead developer and creator is Nick Johnson. So here's the outline of what I'm going to be talking about. So what is ENS, how ENS works, and how to integrate it. Yeah, Oregon represent. Yep, I'm in Springfield. Where are you? Feel free to say in the chat if you want to. I guess you don't have to if you don't want to say. Tigard. Okay, cool. Yep, I have a friend up there. So ENS, Ethereum name service. I'm going to talk about what this means. So first, how is it a name service? So the interesting thing about naming on the internet is it's one of these things that's kind of like lower on the tech stack that just works nearly all the time. So most people don't really know very much about it or think about it very much. So what is a naming service? A naming service is just a lookup system. A lot of people overcomplicate it. You provide a name, it provides you with information back. That's it. Your computer might then do something with that information, but that is separate from the naming service. So for example, in my browser, I go to google.com, okay? What's really happening in the background is my computer connects to the domain name system of the internet, finds out what is the IP address of listed at google.com, sends that information back to my computer, then my computer connects to that IP address, but that just happens all in the background. But DNS doesn't like forward on your connection for you to the Google servers. Your computer does that. It's just in a kind of a middle thing as a user interface thing. That's all. So it's very, very simple. So why do we have naming services? One, because what makes sense for computer identifiers doesn't make sense for humans. So computer identifiers can be automatically generated. They can be just long strings of numbers and letters, obviously. Humans, we like to read and remember words of a particular language that have social context and things like this. So a naming service just bridges the gap. So how is ENS a naming service? So ENS has names. It has owners of names and records that can store any information. So if you have a name, you can look up and retrieve its records and then do something with that info. So for example, this is big confusion on this point. ENS just provides, let's say if I want to send cryptocurrency to Brantly.eth, okay? I type that in. Your ENS provides the wallet with the cryptocurrency address, but then the wallet sends the transaction, okay? So some people think, this confuses people with the fact that we support like Bitcoin and dozens of other cryptocurrency addresses. Like Litecoin, Dogecoin, Dash, all these things. They're like, well, how does that work? Because ENS is on Ethereum. Well, we're just storing the information. So we can store a Bitcoin address on Ethereum in a contract, give that information to your wallet, then your wallet sends the Bitcoin transaction on the Bitcoin network. So why is it the Ethereum name service then? It's not because it's a naming service only for the Ethereum ecosystem. Banish that idea from your mind. It's because it's a naming service built on Ethereum. So the logic and the records are stored on Ethereum, but it can store information relevant to anything. You could store, obviously, another blockchain address. You could store your phone number, your name, your favorite type of cat. You could store any information in the records. So why do we use Ethereum? Because we think it's the best blockchain platform for having a naming service. Advantages include high security and decentralization, ecosystem infrastructure like MetaMask, and for all these things, right? We don't have to reinvent. All these standards, so like all .eth names are ERC 721 compatible, so they're NFTs that they plug into any NFT infrastructure. Programmability, interaction with other smart contracts on Ethereum, even ones that have nothing to do with naming. So composability. Very, very powerful. Other projects that have tried to use blockchain technology for naming, like Namecoin or Handshake, or there's other ones, have their own blockchain. We think that it's much better just put it on Ethereum because that's where all the action is. That's where all the development is. So ENS uses Ethereum to serve the internet, including and beyond the Ethereum ecosystem. And our goal is to make ENS, and therefore Ethereum, a basic piece of internet infrastructure used widely by people, whether they are part of the blockchain community or not. That is our goal. And how are we accomplishing that? Well, we are doing it by, this is related to the topic, complementing the DNS, the existing internet naming infrastructure, DNS tech stack, in parallel, expanding the capabilities of the existing DNS namespace, focusing on use cases not served by DNS, in some cases not possible on DNS. I'll explain more what this means here. But this is how we view ourselves. So how ENS works. So first step, there are no ENS servers anywhere. Okay, this is a big change from how DNS works, if you know how that works. I mean, technically, we do run our website and our manager UI on a web server, although that can also be accessed on IPFS. And you can also interact with ENS without using our UI, because it's just a set of smart contracts. And so you don't need our permission. You don't have to do anything with us to use the ENS, ENS. There are three main parts to ENS. So they're all smart contracts. So the most important smart contract is the ENS registry smart contract. This just basically keeps track of what names exist, who owns them, and then it has a pointer that we call the resolver of where to find that name's records on chain. Although we're hopefully going to be adding the possibility for people to point to have records off the Ethereum mainnet, maybe on a layer 2 or somewhere else. But right now everything is stored on chain. But that's the main smart contract, the ENS registry. Then you have resolvers. So this is a smart contract that stores your records. And then the registrars. So a registrar is a smart contract that creates and distributes names based on certain criteria, for example, a payment. So for example, .eth names, .eth is itself owned by a smart contract that will dispense what are called second level domains. So .eth is what's called a top level domain. Second level domains are just one. So like Brantly.eth is a second level domain. It's owned by a smart contract that will give out second level domains if people meet certain criteria, like if they send Ether worth $5, it'll give it to them for a year or something like that. But all that logic is done by a smart contract, not by our servers. It's a huge change from traditional DNS. All right, so to make, because it's all smart contracts, to make any change, you have to submit an Ethereum transaction. That obviously costs gas and everything. So if you want to register a name, set records, transfer ownership, anything like that, that's an Ethereum transaction, or in some cases more than one. However, resolutions or lookups of records or something like this don't cost anything because you're simply looking up information on the public Ethereum blockchain. So that you're not changing state, you can send Dogecoin to Brantly.eth. There's no transaction, there's no cost involved in that, at least on the ENS part. In fact, this can be done locally. So if you have an Ethereum full node on your local machine, you can do ENS resolution on your own local machine. You're not pinging anywhere else. So that's pretty cool. So what do ENS records look like? So the fact that, so we have the ENS registry contract, which has the names, who owns them, and then you put the resolver where you store your records elsewhere. The reason we do that is that, one, so we can easily upgrade records, but also so that you can create your own record set if you want. Now, we, the team, ENS team, we maintain a record set that we call the public resolver. So it's like the resolver contract for use by the public. And it's like, has all the standards that we've set, and it's what 99.99% of people use. But if you want to take that and maybe extend it, or if you want to change something, you can. But this is what the public resolver looks like. So it just has a couple record types, very simple. It has addresses, so any arbitrary cryptocurrency address. It has a content record, which can store an IPFS hash, a swarm hash, or even a Tor.onion address. We have text records, which allows for any arbitrary information. And then also DNS records. We support all DNS record types, although that's not available in our manager UI. That is in the public resolver. So if you want to see an example for yourself, you can go to app.ens.domains. That's our manager, and search for Brantly.xyz. So that's a name that I own. that uses just about every record type that we support, not all of them, but most of them, so you can get a sense of kind of what we support. So you might have noticed Brantly.xyz, it's not .eth. So let's talk about the namespace on ENS. This relates to DNS. So you've probably heard of .eth. .eth is the native top-level domain on ENS. So it only exists on that. It's not in DNS. It's not in the DNS root or anything like that. It's only on ENS. There's some nice benefits to that. You can, because it's blockchain native, you get the full security benefits of blockchain technology from that. However, we would like to greatly expand the namespace that exists on ENS. Now, we could do that by just creating more top-level domains. The problem with that, though, is that could lead to what's called a name collision with traditional DNS. Like if we make a top-level domain and give out names, and then DNS either already has it or in the future creates that same top-level domain, you could have different people owning the same name on the internet, and that would be bad. It's called name collision. So we want to avoid that. We're not concerned about that with .eth, because .eth has actually already been reserved in the DNS root for complicated reasons I won't explain, but the chance of a name collision there is basically null. But we're not going to create any other top-level domains because it could lead to name collisions. So what are we doing? The way we're expanding the namespace is by taking the DNS namespace and just importing that into our system with the same owners. So we've already done this, or at least made this possible with .xyz, .lux, .cred, .co, .art, .club. Those work in different ways, but we want to have the rest, all of it, like .com, .io, .org, and those should be coming soon. If you're curious about how that works, we use something called DNSSEC, which is a public-private key cryptography system that's been put onto DNS that can prove ownership and prove records and things like this. And basically, you use that to send a proof to a certain smart contract on Ethereum, which can verify that you own a particular name, and then you can use that name on ENS. A mistake that people often make is they think if they own Brantly.xyz on DNS and they claim that on ENS that they get Brantly.eth. No, you get Brantly.xyz. Brantly.eth is a separate name. So I personally, for example, I own Brantly.eth and I own Brantly.xyz on DNS, and I've claimed that Brantly.xyz on ENS. So I own Brantly.eth and Brantly.xyz on ENS. They're separate names. And like I said, most of the rest of the DNS namespace, all that have DNSSEC enabled, should be coming very soon. So we think this is very exciting. So just to make this very clear, soon you should be able to send Bitcoin to example.com and you're using ENS in the background. So that's the plan. Okay, ENS versus DNS. How do our systems compare? ENS has simpler infrastructure. Obviously, we're using smart contracts, not servers. Zero downtime because you can be running it locally. It's decentralized, censorship resistance. We have built-in cryptography and individual ownership. So DNS doesn't have built-in cryptography, although they have this DNSSEC attempt to add this. They don't have individual ownership. You're always trusting somebody else. That means that ENS has better security. We also have, composability. So why does this matter? Why would you want to use ENS over DNS? Something I'll point out is that David Murdoch, so cool, good. Is that everything, I'll say this, we could just use DNS to store cryptocurrency addresses and use that for our naming for wallets and things like this. Like you could have Brantly.xyz and I could just create text records that store my Bitcoin address, Ethereum address, all these things, and wallets could just connect to DNS to do this. We could do this. But why do we think ENS is better? Well, because we have better security and censorship resistance, we think that actually means ENS is better suited for things like cryptocurrency addresses at IPFS websites. So basically payments and decentralized websites. But then also ENS, because it's on the blockchain, has this composability, programmability thing that you can't do with DNS. So this allows for things like names owned by smart contracts, like nobody. You have names that are owned by nobody but still work. You have names owned by a DAO or a multi-sig. It also means that they fit into all the NFT infrastructure. So there's a lot of interesting things and advantages to ENS over DNS. Okay, So you like ENS, you're a dApp developer or something. How should you integrate it into your dApp or your service? Well, the first thing you should keep in mind is the goal. The goal is that every time a user might otherwise see a cryptocurrency address or content hash, they instead see an ENS name. That's the goal. So users should never see just Ethereum hex addresses by themselves. That's terrible UI. It's like, what if the web, you had to memorize like IP addresses or something? It's terrible UI. It's never going to go mainstream. We have to have a naming service that makes for better UI. So that's the goal. So every time you see in your UI, oh, they're having you type in a hex address, or we're showing it here, something like this. Use ENS instead. And it's not hard to do. So specific ways you can use ENS. So the first way, kind of our bread and butter, is what's called cryptocurrency address forward resolution. This is what most people, okay, the telephone network still went mainstream. That's true. That's true. But I'd say, though, it's bad, and we've since created systems to try to get rid of that. Obviously, with smartphones, you put in people's contact information, and you just can like tap their name and things. So there are attempts now to fix that, to make a better UI. So you're right. Maybe it could go mainstream, but we think this is much better. So forward resolution is what most people think of. This is when you provide. Yeah, I don't even know my best friend's number by heart. People used to 20 years ago, but they don't anymore. So forward resolution is when you provide a name and that gets resolved to some data, in this case, a cryptocurrency address. That's forward resolution. So very simple. I want to send a Bitcoin payment or Ethereum payment or something like this. I put in an ENS name. The wallet gets the address, and then I send it on the appropriate network. Very simple. 43 wallets support us. We're in tons of things. This is easy. The other use case is Ethereum address reverse resolution. So this is like you sign into a dApp, and let's say like Uniswap has this, and you sign in, and it knows it can display your Ethereum public address, your Ethereum account address, as kind of like your username. Well, if you have an ENS name and reverse resolution set up, what it'll do is it'll show your ENS name instead, which is, again, much better UI. So yeah, let's say you have something like this in your dApp. This is bad UI. Show the ENS name instead. Okay, so usernames is very similar. If you have a dApp, you could give all your users like a free subdomain, and then maybe set reverse resolution for them or something like this. And again, display that instead. There are services doing this. Another thing we do is IPFS swarm Tor.onion resolution. So let's say you're in MetaMask mobile, and you can type in a .eth name, and it resolves to an IPFS website. This works right now in a bunch of things. This works in your browser, any browser if it has MetaMask. This works in Opera, Brave, MetaMask Mobile, Status, and a couple other things. If you go to our website, ens.domains, we have an ecosystem section that lists all the ways you can access IPFS websites. We also support Swarm, although I don't think there's any browser support for Swarm at this time. We have this thing called ETH DNS, which is a DNS bridge to ENS and IPFS. So this is if you don't have any of those browsers I just listed off, or you don't have MetaMask, you can just add .link to the end of the .eth name, and it will then work in any browser. So for example, right now in your browser, go to almonet.eth.link, and it will bring up the Almonet website, which is a directory for ENS and IPFS websites. It's kind of cool. And there's hundreds of these. There's tons of these. So I mentioned Tor. So this only works in the Tor browser with MetaMask enabled. So if you have the Tor browser and you have MetaMask enabled, and you type in a .eth name that has a Tor.onion address in the content record, it will go to the that Tor website. So for example, I set up a bunch of these. If you go to DuckDuckGo Tor.eth in the Tor browser with MetaMask, it will go to the DuckDuckGo Tor version of that. So that's really cool. We have more information about that on our blog. We also support DNS records. There's actually a couple different ways you can do this. Why would you want to do this? Well, you could maybe have better security and things like this. You know, we're not trying to replace the DNS infrastructure right now because it works really well. We're trying to mostly complement it. Maybe it could eventually replace it. But there is some experimentation with just doing traditional DNS records. So .cred is a top-level domain in DNS that has claimed its entire namespace on ENS. And they actually do two interesting integrations with DNS. One, they've made it so that if you own the ENS version of .cred name, you automatically own the DNS version. So it actually follows ownership. DNS follows the ENS ownership, which is cool. Also, they store all of their DNS records, I think, on IPFS and ENS, and that's canonical. And then they actually also store DNS records on in the normal DNS way, but they follow the ENS IPFS version of it. So that's really cool, very revolutionary integration. Yeah, and then the last use case is everything we haven't thought of. So, you know, we have custom records, we have text records. There are other projects using ENS for things that, you know, we didn't plan it for. So like if you have a project that has some sort of identifier that you think ENS could improve things with, then use ENS. Just use it. You make your own text record. We have a blog post about this, about how, because we have custom text records, any project can have their own ENS record. It's really useful. So that's the end of my presentation here. That's our website, a couple other URLs that are valuable. I think I have about a couple of minutes here. So does anybody else have any questions or comments? You can ask in the chat and I will answer. Does anybody have any questions? If you don't, that's okay. This is your chance. What are some examples of other text records people are using? Good question. So there's a project Umbra, which does private payments, and they have to have some sort of public key, and they plan on storing that in a text record. So that makes using their system much easier. Can you explain the ERC 721 compliance? Yeah, so all .eth names, second level domains on the .eth top level domain, are ERC 721 compliant. Means that they can drop into any NFT infrastructure. So like they're on OpenSea, they're on all the markets. And it'll show up, like if you have a wallet that like shows your NFTs or something like this, your ENS names will show up in that. It's like on Coinbase Wallet or Trust Wallet or something like that. All right, what stops people from claiming DNS domains on ENS that aren't really theirs? So the way you claim DNS names on ENS, you can do this with .xyz names right now. Just Google it, how it, .xyz ENS or something like this. We have instructions. We'll have better instructions here soon when we roll out the rest of the DNS namespace. But the way it works is that you create so let's say Brantly.xyz. The way I claim that is I create a subdomain _ENS.Brantly.xyz. Then I use our UI to basically generate what's called a DNSSEC cryptographic proof, which I submit to a particular smart contract on ENS, which can verify proofs. And if it, on that subdomain, I have to create a text record that says A equals the public address of the Ethereum account that I want to own the name. I submit the DNSSEC proof, and then if it verifies that that is a real record that I set, then it grants ownership of that name to the Ethereum account that I put in the text record. So that means that you have to own the DNS name in order to get the same name on ENS. That's how it's permitted. We also will have a way that if somebody, let's say, loses a name on DNS, that you can delete the name on ENS. And if somebody claims a name on ENS, and then let's say another person that they transfer ownership of the DNS name to somebody else, that new person can take away that name from them and claim it for themselves on ENS. So it always follows DNS. How does layer 2 support look like? So yeah, we've had a lot of work on this. You go to our forum, discuss.ens.domains. Vitalik had a proposal a couple of weeks ago. And we've had a couple of meetings with the community that have been public about that. And we've kind of refined that. Nick Johnson now has a proposal on our forum, discuss.ens.domains, that we will likely be implementing in the next couple months. I'd say within the next year, hopefully. Basically, it's a standard for letting people. So the main ENS core logic will still be on Ethereum layer 1 mainnet, but it'll have a standard to allow people to basically point their records at a different location, like a layer 2, like Optimism or something, and then store their records on that. But that's hopefully within 6 months to a year or something. Is there a more detailed roadmap timeline of when the other DNS names are coming to ENS? So all that are DNSSEC enabled, which are all the ones you've heard of. There's a couple minor ones you haven't heard of that don't have that, but all the ones that you've heard of will be available all at the same time once we just get that feature completely done and out the door, which should be soon. So in the next couple of weeks. I know we've been saying this for a couple of months if you've been following this, but hopefully very soon. It's just, we're literally working on it. It just needs to get done. There's just a few things we're ironing out. What are the fees for owning a .eth name, if any? So to be clear, for DNS names you own on ENS, there is no ENS fee. I mean, you're obviously paying for it on DNS, but there is no additional ENS fee. There is a transaction fee for claiming it, but that's the Ethereum network. It's not from us. For .eth names do have a yearly fee. This is very important. This is an anti-squatting mechanism. You have to have it cost something, or else people will just register up every single name and then ENS becomes useless. For most names, it's $5 US a year paid in ETH so that's for 5 characters and longer. If it's 4 characters or 3 characters, it costs significantly more. The reason for that is that those names are shorter and there are fewer of them and they are more valuable. They're rarer. So basically, our thinking is a 3-letter .eth name should cost more, because if you're not getting a lot of value out of that, you should just get a 5-letter name and let someone else who's going to get more value out of it, such that it'd be worth it for them to pay the higher price. So that's $5 a year. You can pay ahead. So if you're like, you know what, I don't want to have to remember, I don't want to lose my name. Pay $50, then you have it for 10 years. Or pay it for $500 and you have it for 100 years, which is basically forever. We also have various reminder functions in our manager. So you can set an email reminder. You can do a calendar reminder. We have things like that. But the main thing is, if you have a name and .eth name and you want to keep it for a long time, just pay ahead. Good. All right, I've got 1 more minute. Come on, let's stump the ENS person. What are some really hard questions? Jeremy says, thank you. Thanks. You're welcome. Abdul Kadir. I'm sorry if I mispronounced your name. Cool. Very cool. You're also cool. All right, this is the last minute. If anybody has any other final questions about anything. Will it ever be possible to set up auto renewal? I'd say somebody could maybe build a system to do that for you. So you could maybe just trust that you pay them, and you pronounced it well, actually. Good. You could have somebody pay it on your behalf. I don't know if there's some smart contract you could do that maybe could pay it on your behalf or something like this. Like I said, if you intend to keep a name for a long time, I recommend simply paying ahead. I've done that with my names. It's not very much money. If it's 5 characters or more, it's only $5 a year. Like I said, you pay $50, you have it for 10 years, or it scales up to whatever you want. That's what I recommend. But I would say somebody, because ENS is open source and is all just smart contracts, if somebody built a smart contract system or something, or even a non-smart contract system that could do auto renewals for people, feel free to build it. I would say that's just kind of true about the Ethereum space in general. It's true of ENS. There's tons to do. There's tons of work to do. And it's just a matter of somebody deciding to do it. I mean, we can't do everything. Okay, I think my time is up.